Good evening. My name is Ayush P. Menon, and my register number is 23BAI1467. And here's my presentation on the topic Application of Finite Automata in Search Engines. Now, moving over to the PPT. Here it is. So, this is the title slide, of course. And firstly, let us understand what is finite automata. So, finite automata are abstract machines used to recognize patterns in input sequences, forming the basis for understanding regular languages in computer science. So, finite automata helps the user input and helps the user match the user input to the available data that is already present with the search engine. So, in a mathematical way, it can be represented by this given tuple, this one here. So q epsilon, small q, f, and delta. Q is the finite set of states. In this given example, the finite set of states would be a, b, and this final state f that we denoted by. Secondly, set of input symbols. Set of input symbols would be the symbols that the user would enter, and which this automata would consider as input. That would be 0 and 1 in this case, because 0 and 1 are the symbols that's used by the user to communicate with the automata. Thirdly, q, small q. Small q denotes the initial state of the finite automata, which in this case is a. Next comes the set of finite states, which is represented by f. In this case, there is only one final state, which will be represented by small f here, and that would be it. That would be f equal to f. Transition function delta. Now, these transition functions are used to denote transition from one state to another, in while we mathematically represent finite automata. Going forward, types of finite automata. Now, of course, finite automata are machines that can be used to understand and deal with context-free grammar. Here, automata is of two types: deterministic finite automata and non-deterministic finite automata. A DFA is represented by the given tuple q, epsilon, small q, f, and delta. And the main characteristic of a DFA is that for any given input, there is there's a fixed initial state and a fixed final state, and nothing in between. So this helps. This rigid structure of it helps the user to find more concise search results. Secondly, there is non-deterministic finite automata, or an NFA. In an NFA, for any given transition, for any given input symbol, there can be more than one transition. So this can help. This can really help when we have large swathes of data to be uh, scraped or crawled. So these are two types of finite automata. Now, of course, we cannot move forward without highlighting the importance of finite automata in computing. Of course, this is a well-researched topic, and it's widely in use in today's world. Firstly, of course, and a very important point is that it helps in efficient pattern recognition. Finite automata are designed to recognize and process patterns quickly, which is essential for text processing, language recognition, and search queries. Secondly, they found the basis of regular expressions. Regular expressions, or as we call them, regex, are the absolute bedrock of the principle based on which modern uh, search engines work on. So, finite automata forms the foundation for these regex. Simplicity and speed. Now, of course, as we have gone forward, there are other machines like a Turing machine or linear bound automata. These are also machines that we can use to match a given user input to the desired data. However, these are not, however, the most efficient methods. For example, for any given input statement, the time complexity for finite automata could be O of n, and that of a Turing machine or linear bound automata could be O of n square or n cube. So in that case, of course, the simplest solution would be to deal with an NFA or a DFA. And of course, it has other wide range of applications within the entirety of our IT sphere. Now let's understand the basics based on which the search engine operates. So a few keywords are listed over here. First is scrolling, then comes indexing, query processing, ranking and relevance, and result display. Now, of course, engines use web crawlers, which they use to scan and index web pages. Whenever a user gives any user input, it scans all of the given of all of the data it has, and it connects it to the it connects user input to the data that's present already with the search engine. Indexing, of course, once the data is crawled and ready to present to the user, it's stored in an organized searchable index, an ordered array of sorts, which allows quick retrieval from the user side. Query processing, for any query that's presented by the user,